Hello class, welcome to this video on lesson 2.4. So we're going to cover the practice problems from Canvas. So let's go ahead and get started. This lesson is all about calculating the correlation coefficient and the idea of R. So here for question 1, the value of the correlation coefficient whenever it is calculated is never negative. And that is actually false, because remember that R is a value that can be between -1. It could be equal to -1, and it can also equal the +1. It could be 0. The only thing that R cannot be is anything outside of that range. So R cannot be like 1.1 or 1.5 or anything like that. So this right here is false. Question 2, which of the following values cannot be a correlation coefficient? So basically what we were saying earlier. It could be 0. It could be -1. It could be 0.5, 1/2 is 0.5, it could be 1, but it absolutely cannot be -2.5. And so therefore, this is the answer. It can't be -2.5. Question 3, the value coefficient of correlation indicates the degree of how much the explanatory variable caused the change in the response variable. So basically it's saying that when you calculate the R, it tells you how much the explanatory variable caused the change in the response variable. Well, first off, remember that it doesn't indicate causal. Remember that correlation does not imply causality. Okay, so this is a question of correlation versus causation. Correlation means that there's a relationship between the explanatory variable and the response variable, but not that one caused the other. Okay, so this is actually false because of that word caused. Question 4, the value of the correlation coefficient between the temperature and the number of hen eggs that hatch is strong and positive. This indicates that there's a causal relationship between the temperature and the number of eggs that hatch. In other words, the rise in temperature caused the eggs to hatch. Again, kind of like what I was saying in question 3. This is a question of causation and correlation. Correlation does not mean causation. Correlation only means that there is some kind of relationship between the two. Here, we're saying that it's strong and positive. That's the relationship. But it doesn't mean that one caused the other. So this is false. The coefficient of correlation R has no units of measure. That is actually true. R has no units of measure. And in fact, it doesn't matter if when you're calculating R, it doesn't matter what units you're using because they end up canceling out anyhow, and you always end up with something that is unitless. Question 6, the coefficient of correlation is resistant to outliers. So remember, to calculate the coefficient of correlation, you need to take the sum of the z-scores, the product of the z-scores in the response and the explanatory variables, and then divided by n-1. And so in order to calculate R, you need these values. But remember, in order to calculate z, for example, for the explanatory variable requires the variable minus the average over the sample mean over the standard deviation, the sample standard deviation for x. And so remember that the sample standard deviation is not resistant, and neither is x bar. So none of these are resistant. And because they're not resistant, that means z is not resistant. And because z is resistant, that means R is not resistant. So this is definitely not resistant. So this is false. Question 7. Here are the number of enrolled students in thousands and the number of burglaries for 8 public universities and 1 U.S. state. So we have a table here, we got enrollments and burglaries. So fill in the values of the table to calculate the correlation coefficient R for decimals, round to 2 decimal places. So this is going to be key. All of these answers are going to be in 2 decimal places. So in order to calculate this, well, first off, what's the X and what's the Y? Well, it says what we're thinking here is that the number of enrollments in the universities is probably going to affect the number of burglaries. So if you have if you kind of imagine, if you have higher enrollment in universities, that probably means there's going to be a higher chance that there will be burglary in the area because there's more people that could potentially undergo a burglary, first off, right? That are reported, right? Because these burglaries get reported. And so there's a higher chance for those to be reported, and therefore the number of enrollments, the greater the number of burglaries in 1 year that get reported. So with people in the area, there's more valuables and things like that. There's other variables at play, but what we can say here is there's probably a relationship between those two, and probably the enrollment is going to explain the changes in the burglaries. Okay, so X is explanatory, Y is response. So fill in the values of the table. So let's do X bar. That means we got to average these numbers out, right? So X bar number is the sum of the X's divided by however many you have. And we have here 2, 4, 6, 8 people, or 8 things here, 8 universities that we're looking at. So N is 8. So we're going to add these numbers up for X. And then divide by, we have 8 universities. And then same thing for Y bar. We're going to sum the Y's, divide by N. So the Y is 3 plus 23, dot, 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 all the way to 42, divided by 8. That'll give us our X bar, Y bar. And then now to calculate, so let's go ahead and get those numbers first off. Okay, so I went ahead and calculated the X bar and the Y bar on the calculator just to save some time. And notice that for X bar, I got 20, which means that if you want to round this to 2 decimal places, it's technically 20.00. So the X bar here is 20.00. My Y bar is 17.75. That's if you want to round it to 2 decimals. So now we get our SX and our SY. So how do we get those? Well, okay, so let's do SX. The formula for the standard deviation is you have to take the square root of a quantity. The quantity is, well, you have to take the sum of the distance or the deviation from the X value to the mean squared. This is why it's called deviation, because it's the distance from the value from the mean, and then it's squared, and you add them up, divide by however many you have, take away 1. Then you take the square root. The reason why you take the square root is to cancel out the squared that you have here. So that way the squared and square root cancel out, and you end up having normal units instead of squared units. So in order to calculate this, you just got to use the formula. So we're going to take the square root, and we're going to take X, our first X value is 5, minus the X bar that we have here, which is 20. Then we got to square it. Then we got to sum, so we got to add. And then we have to add what? We have to add the next X value, which is 36. So we're following the X values here. Minus, and then the X bar, which we calculated, 20. That's this guy right here, squared. And then plus, dot, dot, dot. And then we repeat that until we get to the last one, which is 31. So 31 minus 20 squared, divided by, and then n minus 1. We have 8 universities, take away 1. You could just call it 7, but I'm just showing my work here. That's how we get SX. And then let's go ahead and repeat that for SY. So we sum the Y minus Y bar squared, divided by n minus 1. So we have here square root. We got Y minus Y bar, 17.75 squared, plus parentheses, and then we have the next one, it's 23, and so on. Plus dot, dot, dot. Last one is 42. All over 8 minus 1. So we can go ahead and calculate these. You can do these on the calculator. When you do this, I highly suggest you use something like Desmos. So if you go, for example, you go to Desmos, com. Well, you can actually type in Desmos scientific calculator. There it is. And then you can actually type in the stuff. So you can say square root, you have a fraction, and then you can type in your numbers. So if we go to our numbers, 5 minus 20 squared, 36 minus 20 squared. To do the squared, you can use this. And dot 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 and continue, and then you do 8 minus 1 down here. So, and then that's how you do it. So I'm going to go ahead and show you and then you continue this off, and then you end up getting a number. So for example, if I stop there, I get 8.28, but I'm going to continue this calculation. All right, went ahead and calculated the numbers. So when you calculate S, you get about 11.44. This is rounding to the nearest 2 decimals, okay? And then 14.66 for SY. Okay, so now we're going to go ahead, now that we got those 4 main numbers, we can go ahead and calculate these numbers in the table. So for the first one, we want to do ZX equals X minus X bar divided by SX. So let's show you this firsthand. So let's do the first calculation here. So we have, for that, we have 5. This is my X right there. My X bar, we just calculated that as well. So that's going to go here. So 5 minus 20 over SX, which we calculated here. So that goes here, and that's 11.44. So we get negative 15 over 11.44. Okay, so you get negative 1.31. So negative 1.31. Here, okay. All right, so, and then we go ahead and repeat that. So the next one would be 36 this time, minus 20 over 11.44, and so on. Now let's go ahead and show you how to do ZY. So ZY is Y minus Y bar. So this time, we're looking at Y minus Y bar over SY. So we have 3 minus 17.75 over 14.66. When you do this on the calculator, make sure you put a parentheses on the numerator, just like I'm doing here. And then you get negative 1.01, because we have to round that because of the 6. So negative 1.01. Okay, and then you repeat that to get the rest of the numbers here. And then for ZX, ZY, you just have to multiply. And this should not say a sigma here. This should just say ZX, ZY. So there shouldn't be a sigma there. So ZX times ZY, we just have to multiply these two numbers right here. Negative 1.31 times negative 1.01. Then you get 1.32. All right, and that's how you calculate all those numbers. And then you're going to rinse and repeat for all the rest of the numbers. All right, so I went ahead and calculated all the values, exactly how I showed you how to do it earlier, and we just kind of rinse and repeated process. So we got all the numbers, and so now once we fill the numbers here, and we rounded it to 2 decimal places, which is exactly what we did here, then you're going to add this last column, right? So this last column, when you add it, gives you your sigma ZX times ZY. So when you add that column together, you get 5.63. Then in order to calculate the R, well, you have to take your total that you did here and divide it by n minus 1 right here. And n minus 1, n is 8, so it's 8 minus 1. So it's basically 5.63 divided by 7, and you're going to get about 0.80. And so that's my correlation coefficient here. All right, so for this one, Joan is concerned about how much energy she uses to heat her home, so she keeps a record of the natural gas her furnace consumes for each month from October to May. She wants to see if there's a relationship between gas consumption and the average temperature for each month. The correlation coefficient round to 2 decimal places. So we're going to be doing the same thing here. So we're thinking that the average temperature is going to influence the average fuel consumption. So this is going to be X, this is going to be Y. Maybe the lower in this case, the lower the temperature, the higher the fuel consumption, because maybe you have to heat up the home, right? So you're going to need more heat, more energy, right? To per cubic foot per day whenever you have lower temperatures. So what we're going to do is we already got X and Y. We're just basically going to extend this column to do the ZX, which recall is X minus X bar over SX. And then we're going to continue and do ZY, Y minus Y bar over SY. And then lastly, ZX times ZY. And we're going to continue this, right, for all of these. But I'm not going to show you all of those. I'm not going to show you those calculations because we kind of did it over here. I'll show you for one of them. And then you'll just rinse and repeat. So first off, you need to calculate your X bar and your Y bar. So you're going to have to add up all of these guys, which is what we do here. So we're going to add up that total, divide by N. N is how many people we have, or how many, in this case, how many months. 1, 2, 3, 4, 5, 6, 7, 8 months. So that's going to be divided by 8. And we're going to add up all these numbers here. So 49.4, dot, 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 all the way to 57.1. And then divide that by 8. And we're rinse and repeat for Y. 520, but this time we're going to do all these guys. Plus 610, plus dot, 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 all the way to 250 over 8. And we got to do the SX and then the SY. Okay, so I went ahead and calculated those averages for you. So we got 40.76, we got 615.00 because it's 2 decimals. Then we got the SX. Remember, to calculate the SX, you have to take the square root. You add your X minus X bar squared divided by N minus 1. So basically you have to take X, which is 49.4, this first X value, minus the average that we just got, 40.76 squared plus dot, 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 all over 8 minus 1. And I won't calculate that. I'll just have you do it as an exercise. This is just kind of showing you what to do. So we have, the next one is 520 minus 615 squared plus dot, dot, dot. Do it for the rest of the numbers over 8 minus 1. Then once you calculate those, you plug it into this formula to get ZX and ZY. Then you multiply them. Then you add this column to get the total. Then you plug it into R. This total into R, and then divide by N minus 1. If you did that, you're going to get 0.96. I believe it's 0.96. No, it's 0.98. So 0.98. All right, to 2 decimal places, and that's going to be your final answer. All right, guys, that's going to do it for the video. I hope that you found this useful and that you learned a couple of things, or if not, just refresh your memory, and I'll see you in the next one.